My name is Jaroslav Jeruše. I am from a Tescan company. I am the coordinator of the UnivSEM project. I work here in Brno in a R&D physics group as a leader of that group. So in the project it was very interesting for me to develop a new kind of scanning electron microscope and also integrate it with a focus ion beam, and also to integrate all the other techniques coming from project partners. It was also a challenge not to manage only the local development team, but also the international team consisting of several academias, university and industrial partners. For Tescan company, the project is interesting not only as a means for financial support, but also for acquiring new knowledge and getting into the European nanotechnology community.
My name is Olaf Hollricher. I'm one of the founders of VTech and I'm responsible for research and development at VTech. At VTech we produce confocal Raman microscopes, or mainly confocal Raman microscopes, and the project we are in here in the UnivSEM project is to develop a confocal Raman microscope that can be operated in the vacuum of an SEM, so to combine confocal Raman microscopy with SEM. And this project is working very well for us. We already introduced the system, we call it RISE, Raman imaging in the SEM, and we already got a lot of interest. The point is, we can, as a small company, we cannot, without help of these kind of European projects, we cannot develop such a complex system on our own. Therefore, it is very helpful to have this kind of universal project to help us develop on these kind of systems.
My name is Oliver Schaff. I'm coming from the company Spec Surface Nanoanalysis in Berlin. We're a company of 150 people building scientific instruments for the ultra-high vacuum community, and those instruments are used for studying surfaces in ultra-high vacuum, very clean environment, and are mainly used by scientists worldwide. Our involvement in the UnivSEM project is to add another imaging technique, another microscopic technique to the UnivSEM universal tool. Our instrument is complementary to the SEM, the scanning electron microscope, and our instrument is called SPM, scanning probe microscope. An SPM has advantages and also disadvantages compared to the SEM, that's why it's complementary. And I would say the main add-on to the SEM technique is that we're adding the quantitative topography information, and SEM, a scanning electron microscope, has no information on the depth of the sample. It can image laterally in X and Y, but it cannot so much measure how deep something is or how high something is on the surface. So the first thing an SPM adds is very precise height information and also lateral information. It is also a scanning technique, and instead of scanning an electron beam in an SEM, an SPM scans a tip over the surface. Since we're part of a European project, it's probably also interesting to say why a company like Specs would like to be involved in something like that. And the reasons are manifold, I would say. I mean, there's, of course, for a company, there's always one kind of trivial reason. We want to sell instruments and improve instruments, and we want to add our know-how to the scientific community. And the instrument which we envisioned in this project is a very promising instrument. It's a universal SEM, and this has not been built so far. So we, as a company, Specs, also hope that this is a field where we can sell instruments. So this is the, let's say, the very obvious thing a company might be involved into such a project. We started to come together in the first meetings to prepare the proposal, the UnivSEM proposal. We immediately saw that the group, the consortium, is a very, very strong consortium. So we have been involved, we company specs, and also myself as a technical director have been involved in many proposals, and this was definitely the strongest one I saw so far. For many reasons. So I think one of the reasons is people. So those people are very strong in the consortium, just very good characters, good scientists, good salespeople, good companies, good universities and technology institutions. And it is very special. And for a company like us, it's interesting to widen our network. So this is kind of networking, not that we immediately benefit from the cooperation with these other institutions, but I'm sure that we will do in the future, and especially with that kind of strong cooperation we have and strong partners in this proposal. So in general, this is, I think, one of the reasons why EU proposals are funded, and I think here we have a really, really good example, and that was immediately visible from the beginning that this will work and that those companies are very strong. So for us it's a very important networking opportunity in our technology world, in this corner in which we are working. So all in all, I'm really glad that we joined this project, and it turned out to be extremely successful for specs, but also I think for the instrument and in the end for the customers, which is the most important thing, which will use the UnivSEM instrument.
My name is Fredrik Östland, and I work at TOF-SIMS as a programmer, and I'm also the project manager for our FP7 tool. TOF-SIMS' role within the UnivSEM project is to enhance our existing TOF-SIMS accessory for the FP7 chamber. We are also helping integrating our technique with other measurements technique within UnivSEM. Especially the SPM is interesting for us because it provides true depth information for our SIMS datasets. UnivSEM is important for us because it allows us to maintain connections with our previous collaborators and to get new collaborations, like with specs, for example. It also provides us funding to develop a product which we find is very interesting and has a big potential in the future. I find the project as such very interesting, and it gives us more resources to test things that we otherwise wouldn't have tested probably.
My name is James Whitby from EMPER, the Swiss Material Science Institute. We've been working on the UnivSEM project now for 2 years, and EMPER's main goal in the UnivSEM project is to work with the manufacturer of the secondary ion mass spectrometer and to help them improve the software and the hardware by providing a rapid testing cycle, and to include EMPER's experience in actually measuring real samples. EMPER have a strategic interest in integrating measurement techniques. We have our own atomic force microscope, we have our own plans to put Raman in vacuum, and so in this sense the UnivSEM project is very complementary to our own interests. In this project, EMPER's benefit is largely to have the most recent revision to the software from TOF work, but EMPER are more giving than receiving in this project. So we have a lot of experience in these measurement techniques, and by helping to steer the software and provide technology transfer to industry, we're fulfilling our government mandated role.
My name is Björn Hoffmann. I'm working at the Max Planck Institute for the Science of Light in Erlangen in Germany, and I'm both a PhD student and also head of the lab of electron microscopy. I worked together with Tesken for 5 years now, and we were already partners in the project before called FIPLIS, and we were coordinator in that project. And now in UnivSEM we are also a partner with a specific task, which is the benchmarking of the Raman add-on to compare it with typical systems that are installed into an SEM. And also our second task is to generate applications, because our group has a very high expertise in complex nanostructured samples, and these are perfect to benchmark the system, the UnivSEM prototype, and we use samples from the fields of photovoltaics and life science, and also lighting, so light emitting diodes, to show the possibilities of the prototype. To be a partner in UnivSEM was really beneficial for us, because we learned a lot about our projects, about our research, we were able to solve a lot of mysteries in the last months, and in the next 12 months we will also be able to measure much more samples and to also publish our research in high impact journals. And I personally benefit by the project because it somehow gives me my PhD thesis and also increases my knowledge in correlative microscopy, so it shapes my scientific profile.
My name is Tomáš Šikola and I am from Brno University of Technology. The project UnivSEM is a nice platform for doing interesting applications in the field of nanotechnology. In the UnivSEM there are equipment which comprises a lot of interesting and sophisticated methods, ranging from scanning electron microscope, focused ion beam, atomic force microscope, and last but not least, Raman spectrometer. And by this method we can prepare nanostructure to characterize them, and I would like to mention especially very nice applications going into plasmonics, where in fact we can study photoluminescence enhanced by plasmons. And the project is beneficial for us in terms that it's a natural basis for meeting top respected institutions coming from fundamental research, applied research, and also from industry. And it makes us possible also to participate in an interesting research and to use students for that.
My name is Rudolf Friček and I'm responsible for the project management of UnivSEM project. I'm coming from an Amires consulting company and we are responsible for administrative and financial project management and dissemination activities of this project. Recently we have presented the results of this project at the Industrial Technologies 2014 conference, where the results have raised a lot of attention from a research community. This project is particularly interesting and we are proud to achieve already the several successes which made already prototypes and products on the market, which in fact is justifying this SME targeted activities which are co-financed by the European community.